right, thanks very much. Go directly. One of the things about being an old programmer is I can't always tell people what they should do, but I often can tell them what not to do, mostly because I've done it and it sunk the ship. So this is one of those despair.com posters. Is my value at this conference is perhaps I just am meant to serve as a warning to others about what they shouldn't do. I'm really enthusiastic about being here. At the New York event, the enthusiasm came from just seeing the explosive growth in serverless, the work that a cloud guru is doing. When I left Dell, I was an executive. All I ever did was PowerPoint, go to meetings. Now I'm configuring the API gateway and writing JavaScript, so I'm getting back to being an engineer. I thought about why I'm excited about coming to London, and I've come to the conclusion that I'm not going to be able to hear the US election crap for a week. But I do have to go back a week beforehand, so if you like this talk and you'd like me to speak anytime over the next 2 or 3 weeks and perhaps the next 4 years, please don't hesitate to ask. Objectives. I want to help accelerate the widespread adoption of the serverless technology, and I'm going to share experience. I've been helping 2 groups of people. In our startup, we have a small, experienced team, mostly Java programmers, mostly J2EE programmers, and I talked a little bit about this when I spoke in New York. One of the changes since New York is I teach at Columbia University. I'm an adjunct professor. I'm currently teaching a course on building serverless applications. It's incredibly popular. I had to cap it at 60 students, which is a lot for a master's level course. And it's been very interesting seeing how difficult and how rewarding and how strange it can be to try and teach serverless programming to experienced university. Basically what we're doing in Sika, it's the company that I helped found, is real quick. On one end of the spectrum in television, there's a huge number of people that want to produce TV content. Hundreds and hundreds, if not thousands. You see them at web festivals. And then there are the people that want to watch the content. But there's this huge intermediate layer, which are the people that actually send the signals, either the satellite or the cable, the networks that fill programming, and then larger production companies that support the network. The biggest problem is this really disintermediates. These people cannot directly interact, so they can't find content providers, they can't work with them, they can't support them, and they can't form communities with each other. So we're working to fix that so that you just go through the cloud, it's web streaming, web delivery, and independent producers can build communities, get a presence on social media, and people can find each other, et cetera. Now, the only reason I tell you this is because when I talk about some of the things that we're currently lacking in serverless and things that I think the community as a whole needs to resolve, it'll become clear, but it helps to understand that we're doing streaming, television community, et cetera. This is the technology that we're currently using for the alpha or the beta. I just put this up here because I'm going to allude back to it. We're currently using mostly a core. It's sort of a standard 2-tier, 3-tier web application. We use S3 and the CloudFront CDN for delivering static content to the browsers, JPEG, GIF, HTML, and our Angular JS code. We have the API gateway, so the Angular we deliver uses REST Angular, but it makes REST calls through the API gateway to our Lambda functions. We implemented the Lambda functions in Java, and I'll talk about why we did that in a minute. And we currently go to a relational database, although we're going to increasingly start going to things like Dynamo. Elastic Beanstalk for a couple of things that we do. And then the rest of these are things that are around the environment. So there's a lot of stuff that has to change as we do lifecycle management. So in theory, we could have to reconfigure the API gateway, push out new Lambda functions, change a database schema. We have to version these things. So we use code commit from Eclipse and kick off Jenkins, but this is becoming unworkable. So we're going to need to find tools that help us with this because there's just so much stuff that's going to change in so many different environments. And then we actually are shipping email delivery, so we have a connector that calls out to Mandrill for MailChimp. The reason that we use that instead of the email services is it's got very good support for templates for emails, and also if you need to do a mass mailing or send emails to a lot of people, like you want to announce that there's like a new series that they can see, it has templates, workflows, et cetera. So it was really good for that. And then some other stuff. CloudWatch for monitoring, that's been really quite helpful. It's the primary mechanism that we have for debug. So like I said, I'm coming at this from two directions. We have an experienced Java team. They've got mostly relational database experience in Angular and HTML. I think our biggest gap in this space is we decided to focus first on a browser-based application, and it's been extremely interesting trying to actually get that browser-based application to work on iOS and Android. Because very, very subtle things would happen. Before iOS 10, if you were playing a video, the iOS device really wanted to go into full screen mode no matter what you tried to do, and we're showing comments floating, so we need to kind of have control of the frame. So we must have had to go and find 3 or 4 JavaScript libraries that would sort of hack this. It's not directly related, but this is one of the challenges. The college seniors and master students, broad-based skills, no experience being part of large software development projects. So I have them form teams. They do about 5-person teams, and they'll do a project every 2 weeks. And one of the things I've observed, and this is going to tie back to the broad-based adoption, is they are unaware of common design patterns that experienced programmers just take for granted. They'll do crazy things. I mean, they'll write a Lambda function that takes the incoming, JSON, parses it, calls the business logic, calls Dynamo, calls the relational, returns it. And, you try to explain to them, like, okay, what happens if the database schema changes? This may not have been a good thing to do. So part of what I do is at the beginning of class, I tell them that I'm the Lex Luthor of software. So every time I find them doing one of these design patterns, I make them do something that teaches them a valuable lesson that they're not going to forget. And an example of this is I have them do an address lookup. So somebody types in an address, they have to go validate it. They built a Dynamo database. They had the code sprinkled in there. I said, okay, fine, now you're going to go use the US Postal Service and call a REST API. All those places you had sort of coded in that you assumed you had address. So despite this, the course is quite popular, despite all of this. Also, in addition to the election, I realized in the US it's not a problem, but outside the US, an American with a laser designator can actually be kind of a scary thing. Because we don't do good things with them. This is the basic structure of the app that we build. And this ties back to some of our experiences. We have a set of basic modules. So these do a contained piece of work. So we have one of them that manages the basic user information. We have one of them that does content management and catalog. So if you think about it, when you're delivering television, you've got property. It's a company that has lots of franchises. Franchises, typically the way an American would say series. So, Big Bang Theory or something like that, seasons and episodes. We have to do some catalog management. Social media, we will go out and connect to Facebook, Twitter, these other things, but we basically need a library for doing that. And then we add other ones in. This is pretty straightforward. There are some problems we encountered in these individual places. And then we have a set of services that kind of compose it together, integrate it, give you a higher level value proposition. A simple example of that is if you're coming in and asking information about a user, you probably want to get stuff from the basic user information. What's their email? What's their last name? What's their contact policy? But you'll also have to go in and pull some information potentially about social media. Now, doing this way was really good. The problem is when you're in this layer, you are effectively trying to do a join across two web services, across two REST interfaces. You don't want to push that out onto the browser, have it call the two and merge it, because the schema and the type will change. But we really haven't found a good solution for this composite behavior. When a request comes in, you've really got to pull data together and do what's the moral equivalent of a join. So that's one of the hardest things that we had to struggle with. We actually bypassed that and cheated, which I'm not happy about, but we will actually go around. We know what databases these things are in and actually drive the join behavior through the SQL. Really makes me nervous, but that was the only solution that we could come up with. So this is one of the gaps, is this type of composition. Course description, I'm not going to go into that, but these are the things. I'm basically trying to get the students to build a simple version of the product that we're building in the startup. So basically having them do all the tasks. After action report. This is a thing that comes with the military, what worked, what didn't work, what will we change. And so this is the after action report from both the experienced team and the university students. Students, virtually no knowledge of the body of work out there in design patterns. They will show me my code, and literally I will look at that code and go, dude, that is page 2 in the anti-pattern book. Like, just don't do that. You could sort of expect that kind of thing. The problem is, if you think about it, as you start, this gets progressively worse. If you've got monolithic services and they're not following patterns, you've got a few coarse-grained patterns, so you can just sort of know, I got to go here, I got to go there. When they go to microservices, you have a lot more code with the anti-patterns in them. When you go to function as a service, you have little pieces of code all over God's green earth with these anti-patterns in them. And so if you need to change something, you've got functions reacting to events all over the place. And so it makes the anti-pattern problem worse. And they have a mental model of everything is in a file path. So that's the way Node teaches them to teach. That's the way that Java teaches them to think. That they can't figure out how to share code between Lambda functions. So it's been a very hard. So I would say those are the two biggest things. The experienced team, it took us a long time to figure out a serverless plus functional plus stateless, and mostly for configuration, because we have to start our code up and then do some config. So we have to connect to a database. Okay, what's the database URL, right? Where do we go get the password? What services are we going to call? So the basic mechanism that we have is request comes in, we set up an environment, call the function, take it down. Well, config files don't really work on Lambda. You can basically put it on the temp file, but does it work? You can put it in the class, in the class path, and then just load it as a file from the class loader. You could put it in an S3 bucket. You can code it in as constants. There's really no good, generally accepted solution to this. We do something very simple, which is our model is, well, if we were going to change a config file and put it in the class path, would it basically have to upload the jar file again? Well, why would we do that? So we just have a Java class that's got all the constants in it, because what would happen on initialization is we would read the temp file, load the Java class up, and we'd have the constants. So we use a Java class as our config file, and then if we have to go change configuration parameters, we will go and rebuild the jar file and upload it. And we're still trying to figure out how to do metadata-driven components. Anybody who's done significant development, as you do a pattern over and over again, you sort of realize, okay, I don't need to do this in code. I can have a metadata file that interprets it, it does it. And so you now have another artifact, the code, the metadata file, the config stuff. So we're still trying to figure out how to do that. So those are the big lessons. Smaller lessons, going to this technology significantly improved productivity of a small team. I've managed large organizations and also ad tech teams. My rule of thumb is if you've got 100 people, about 15 to 20 of them are actually going to be focused on just setting up and managing the environment and the infrastructure for tests, delivery, code build, et cetera. We don't have any of that. Everybody works on writing functional business value. So they're writing code that actually focuses on what the application is trying to deliver and what's differentiated. And in general, we don't worry at all about availability and scalability. Exactly the same code that we unit test in Eclipse is what runs up in the Lambda environment. We don't have to worry about having a test configuration and a scalable configuration. So I would guess that saved us about 20% in terms of person resources, and also probably significantly more than that in time to value, because you put these build, test, dev things in the critical path of doing something. Very incremental deployment and versioning of code. This is kind of spooky. So I think over time, this is going to be one of the things that's really differentiated relative to microservices, is I can change the implementation of any method on any path without touching anything else. So if I've got what I think of as a microservice, customer with ID, that's got a relationship, and this is all in Java, I can go and say, well, I want this method here to be this separate JavaScript file. I just basically, it's almost like patching it, saying, okay, I want this thing here to be different. And that you really can't do in microservices or any other technology that I've seen. So one of the analogies that I use, and I think one of the things that's really powerful about this, is since you're attaching functions to URLs, it does for programming what wikis did for static content. You can basically go and say, look, this URL, I want to edit it. I want to change the way. So you're almost like you're programming the web. One configuration of code per path and verb. You don't have to worry about all these class path collisions and other things that happen. These node modules are not compatible, because on any verb, you load the environment, run it, and take it down. So we've never had a class path problem. And I've never been in an environment in Java where when you tried to start a server, the class paths didn't stomp all over each other. And I think that is really valuable. And you can do incredibly incremental testing. And so what we've found is we basically do a local unit test on local resources. So we will run in the environment, just basically call as a Java main this particular function. Since Lambda is serverless, we would have to initialize the environment anyway, so we just call our initialization code. We connect to whatever local emulators, so is it MySQL, is it the local DynamoDB, run the code, and take it down. Then we do the same thing, but we connect to the remote AWS resources. So we'll connect to MySQL in AWS or the real DynamoDB. We can then upload the code and run it in the AWS environment in Lambda. Then we test, we go back and instead of Eclipse, we actually go onto the console in AWS and just send the same JSON in. This is really just paranoia. But in the long term, only the paranoid survive. If this works and that doesn't, it's really not a code issue. It's something in the environment. We test. We have a command model. So instead of going directly to the paths, any function we have, you can basically send a command to a command processor and say, run this command. It causes some weird things from a conceptual point of view, because to do a get, you actually are posting a command that's going to call the get. And that kind of messes with people's heads. But the primary reason that we did that is we will then go test through the normal REST path. If the command works, but the REST path didn't, we know that the problem was in the way we set up and configured the API gateway. The mappings are wrong, we're missing mapping a header, et cetera. So we really have to decouple, is the code working properly in the AWS center over HTTP? And this test will handle that. If the REST path works, then we're fine. If the REST path doesn't work, we've decoupled the gateway problem from our actual code, and then we do performance and scale testing. What didn't work and what did we screw up? Web application design, for reasons decisions that were made before I joined, there's basically two ways to build a web application. You can either do data out, so I'm going to define the data model, then I'm going to build the functions, and then I'm going to build the user interface. That was the path that the team initially picked. The alternative model is you start with the page flows, the forms, you decide what verbs you need, and then you go to decide what the data model is. Starting with the data model out, it just basically caused no end of grief with mappings. So in hindsight, we should have started basically with the APIs going in, and literally that's what we're doing. So I think one of the best things that's happened to us since we started with Swagger Hub. I mean, we basically do all of our initial design in Swagger Hub and then push out from there as opposed to a more classic approach. So Swagger Hub's been a big help. Java. All kinds of weird stuff happens in Java in Lambda. It can be quite entertaining. One of the bugs that I've found is the mostly stateless JVM. Basically, if I was going to give a demo and I would run the demo, I was like testing and running the demo would work. But if I stopped, if I'd like test it and then wait 15 minutes, it would work. So typically what do? Like you do your code, you're testing, and then you say, okay, we're going to give a demo. If you retested the demo like 2 minutes before the actual demo, it would fail. It's like, what's going on here? It turns out that if your mental model is you're getting a fresh JVM, they have optimization and caching, and so you'll get the same JVM back, and if you have had static class initializers, those values are set. So it's a mostly stateless JVM. That caused no end. The mapping. Now, the obvious question is, why did we pick Java? And the standard joke is because since I'm up from IBM, COBOL wasn't available. When I told this joke at the New York conference, Tim Freeman actually said, well, actually, there is a way to do COBOL. At which point he said, oh, that's interesting. What I thought was, please get the hell away from me. But in terms of using Java, it's Stack Overflow, these places where we go to find things, there's just nowhere near as much of it out there. I mean, it's pretty clear that the two preferred languages are JavaScript and Python. Students don't have this problem. One of the things that's interesting is, and I've seen this on several semesters, probably of the past 100 student projects I've seen, less than 10% of them use Java. The rest of them are actually JavaScript, Python, or some other language. So these Java-centric ways of thinking are gradually going to die out. Configuration and property management. This was very difficult. We tried several approaches. I don't think there's a really good standard approach to this. The default that you will see if you go to Stack Overflow is load your properties from an S3 file. The problem with that is that if you're trying to do something quick, like I'm getting a request, I want to go put something in a database, now you have to do two things, read S3, call the database. Read S3, do this. So in essence, you're doubling the number of IOs. I'm not sure that actually matters too much, but old guys don't like to do that. But in general, it's sort of two things have to happen. And we came up with this solution that actually has the config and the code. Probably the biggest thing that's biting us now is software change and configuration management. When we push out a new version, we have to push things into S3. We have to go and push things into Lambda. We have to go change the database schema. We have to keep the old version working. We're going to go and start using SQS and other things. So this is becoming a serious problem. I know that there are tools that are emerging, but software configuration and change management, especially the thing we're hitting in now is database schema evolution, are the things that didn't work. What we'd really like to see differently? Start with the API in Swagger and generate everything from there. This is the model that we're going to switch to. The students actually, I told them to do this and they've derived tremendous value from it. So the Swagger Hub-centric approach has been really popular and really useful. There are certain things that you can't generate from Swagger Hub though, like the implied schema of the DynamoDB and the accessor functions for the DynamoDB or the database. So in terms of the basic API gateway, Lambda function client, it's really good, but you can't really define the downstream things, like if you need an SQS queue or you have an implied database schema in Dynamo or relational. As I said, I would have thought a lot more carefully about query. If you look at the way Swagger works, it teaches you to think in terms of paths. So path, path variable, path element, and then query string. That works really well if you're like trying to query just in that path. But if you are basically composing higher layer paths from subpaths, you really can't implement that easily. And so that's causing us a lot of problems. We're cheating by going around it. I really don't like doing that, and we're going to need a better solution for that. The API gateway was a nightmare. Originally, I told a joke at the New York conference. I did a lot of work on WebSphere. Tim came in there and symbolically bashed servers with a baseball bat. So I got a USB key, said, trust me, WebSphere is installed on here, and then I took a Harry Potter wand and tried to destroy it. I was going to do that here, but apparently you cannot get wands through airport security. I don't think they believe in magic, but airport security, I don't know what this in equals bad. I don't know what this is equals bad. So yeah, you can't get them through security. Interesting. By far the biggest issues are, there are three things that we are struggling with now that we can't easily get from any of the cloud providers. For the types of applications we're doing, it's critical. The first one is a content management system. If you look, things like Dynamo or document management, things in terms of documents, content management is more than that. It's, I want to go and say, please find me all the comedies that, are in this series. Or I want to go and add things and then add the catalog front end and publish it. So in Java, a JSR and content management subsystems emerged. But we really, if you are going to go deploy a show, you got to put the video file out there, you've got to put the thumbnails out there, you've got to put the description out there. We don't have this content management driven approach to pushing data and versioning stuff and doing the types of search doing content management. So we have to hack that stuff on top of a relational and also on top of a cloud digital asset management system. Second one is people can chat with each other when they are watching videos, and there is no generally accepted cloud presence and chat interface. So we actually have to spin up an XMPP server. I'm not really happy every time we actually have to spin something up on EC2. It seems to defeat the entire purpose of serverless. But there really was no good XMP instant messaging chat interface. If you look, the recommendation is use SNS, but SNS is not really, aimed for this type of interactive chat. You need something on top of WebSockets. You need something that's going to track presence, who's logged on. I think you could do this with a layer on top of SNS, but we decided we were just going to spin up XMPP, and then the big one that's getting us now is graph database. When you do entertainment-based delivery, you ask all kinds of questions that you can't easily answer with a DynamoDB or a relational database. Like, please tell me all the shows that my friends watched that have Tom Hanks in them. I mean, writing those queries on top of a SQL database or on Dynamo is a nightmare. These things are out there in the cloud. For us, we hacked stuff on top of the infrastructure. So we did XMPP server. We did a simple content management system, simple graph. The students, I basically make them use web APIs. So there is somebody that'll host Neo4j. There are cloud content management. But the problem with that in production is you start introducing additional targets in your lifecycle and change management. You've now got a lot of things that you need to push code and configure out on AWS. Plus, you need to go through non-standard APIs to go change your schema in the content management system or go and change the schema in some remote cloud environment. And then we're going to get into monitoring problems. A request came in, it didn't come out, where did it go? Well, if I spoke to 7 clouds, I'm typically not going to know the answer to that. So for the production and the product that we're building, we keep it contained, but that is not a good feeling. And then improved local test capabilities. And the biggest one I would say is it would be good to have something that emulated the API gateway locally. because you really can't test talking to something through the API gateway without actually pushing the code out into the data center. So in terms of things that we would do differently or like to see, these are the big ones down here. So those are the experiences of both experienced programmers and trying to teach students how to use this technology. Do we have time for a couple of questions, right?
Yeah, we do. We've got
just so you know, stunned silence is common after I speak, so I will not be offended if there are no questions. And I have a laser pointer. I am an American, so I'm not optimistic about questions.
So, does anyone have any questions? I have a question. Just around, you're talking about you have the ability to chat with people while watching video. Is that chatting in real time, I presume? Is there anything to stop people from posting spoilers? Like, what's to stop someone from, saying it, Han Solo gets killed?
Well, these things are actually called watch parties. It's not open to everybody. You basically invite people to the watch party. So basically, it is the online equivalent of like watching it in the room with them. And presumably, you don't invite somebody a second time if they do that. But no, there's no general. I mean, part of so that is with respect, to the friends. You can also chat with the content providers. So they're notified when there's a video, and if you were an actor in a show, you can get notified and asked to participate in the conversation. So there's nothing that stops that per se, but you have that problem even when you're commenting on something like YouTube. There's no standard way to solve that problem.
Okay, yeah.
So you said that basically you're lacking CMS, GraphDB, etc. presence.
Right.
So how did you get around that problem?
For content management system, we basically merge two things together. We do the basic functions on top of a relational database. So the basic folder and search by tag keyword. We do that on a relational database. It causes some weird queries because sometimes you have to search the tag table and then go find the content instance. So we can do that basic stuff, and then more advanced things. We actually use Brightcove, which is an online digital asset manager, and that handles things like the transcoding, the right versions of things. So we had to merge those two things together. But now we're beginning to see some issues with having it done on top of a relational database because as the content providers are actually starting the onboarding experience, they keep asking for additional capabilities. An example of this is our first mental model was, okay, we're going to have series and seasons, Big Bang, season 1. They come in and say things like, what about the Christmas specials? What about this or that? Those things are easy to do in a CMS system. It causes us, sometimes we have to change the schema for that. So we did something very simple for the CMS system. For graph database, we did a graph structure on top of relational. So you can ask simple questions like, please give me all the objects that are related to another object, by this type, or have this property. That's fine if you're going one hop, but if you're trying to do transitive closure, it's a real pain. So we can do one hop on top of relational. The students, I have them calling graph I'm going to actually have to switch over to running Neo4j or something like that in an EC2 instance because we're just not going to be able to continue to do the relational. And we run a Jabber runtime in an EC2 to do the chat and messaging. The thing that worries me about that is scalability. It works as long as you only have one server. Then you start getting into this, I need to configure for scalability. So when you're a small startup, it's fine. But I'm worried about scalability, so we actually use an EC2 instance for that.
Okay.
All right.
Well, thank you very much, Donald. We appreciate it.
Thanks very much.